All right, for number 16, we have a polynomial. And when we talk about polynomial, it's not something that students will like it at the beginning. Last year, I would say I definitely saw a lot of students struggling because I think they just lack the tools, they lack the understanding of interpreting what they're seeing with this little equation. So the first thing that I want to say is that every single bit of what you see here in the function, it's going to indicate something. Okay, it's going to indicate something, every single bit of it. And I will go from the simplest, and then we will slowly ramp up the difficulty and talk about some advanced stuff. So the way I want to start with the polynomial function would be something that's very straightforward, and that is the x and y intercept. Okay. Now, I hope that you're okay with all these parentheses. These are all the roots, okay? They are called the root form. So you have x, you have x minus 4 and x plus 2 as the factors. Right now, let me make sure that we are clear on a few terms. And I strongly encourage you to speak it out loud, okay? Although you're just watching a video, but I can hear you. I can hear you if you have said it, okay? So make sure that you all say it out loud, that these are all factors, okay? All right, and factors would give you the idea of what the roots are or what the zeros are. So if you know the factors, then the roots that we see is that x is equal to 0, x is equal to 4, and x is equal to -2. Okay, so we say 0, 4, and -2. I don't care if you put it in this order or any random order. I don't care, as long as you give me all the zeros and roots. Okay. Now, if you happen to not know what we mean by the roots, well, it means that these numbers will result in y, or in this case, f of x, equal to 0. Okay, or actually, when you plug in all these numbers, like f of 0 would be 0, f of 4 would be 0, f of -2 would also be 0. Well, how? Well, think about this. If x is 0, well, this will be 0, this will be -4, and this will be +2. And we have to the fifth power here. 0 squared is just 0. So you multiply everything together, you get 0. Okay. And then if you say, well, what about the 4? Well, that would be 4 squared with a negative up front. And then 4 minus 4, it's going to be 0 to the fifth power. And then you have 2. Okay. And again, you are multiplying by 0. So you get 0. So that's how we have factors, how we value factors, and how factors are actually helping us to find out the roots or zeros. Okay. And once we know them, okay, once we know them, we will plot them on the graph. We have 0 right here, -2 right here, and we have 4 right here. Okay. Now, and I'm going to give out the first warning for this problem. Okay. My first warning is this. These 3 are your x-intercepts. They are your zeros. I repeat, these 3 dots are your x-intercepts. There will not be any more in the future for this question, of course. Okay, I repeat, you only have 3 x-intercepts. You will not have the 4th one. You will not have the 5th one. Okay, I'm not going to repeat this. And I will tell you why I say this warning later on when we start drawing the graph. Okay, y-intercept. What's y-intercept? Y-intercept is when the x is equal to 0, right? Okay, So you would go ahead and say, what's f of 0? Well, f of 0 is 0. We actually talked about it earlier already. So y-intercept will be 0, 0. Now make sure that you are not writing a single 0. When we ask for y-intercept, we are talking about a particular point. So make sure that you are using the expression of a point to represent a point, which is 0, 0. Okay, all right. So we have the y-intercept, x-intercepts. I think we are good for the first level 1 stuff. Okay, now let's go ahead and head to level 2, and that is finding out the degree and the sign of leading coefficient. Now, I'm going to put it this way. The sign of leading coefficient is very easy to acknowledge. It's just this part right here, for the most part. Okay, for the most part. It could be more complicated if you see that one of these factors, it's not like x minus something or x plus something. That could cause a little bit of a complication. But for now, everything is normal. Don't worry too much. So we have a negative coefficient right here. Okay. And then the degree, it's going to be the most challenging part as of now. Last year, I've seen a lot of students missing this question. So now, I'm going to give you a few choices. What is the degree? You have choice A, 2. Choice B, 5. Choice C, 8. Okay, so you got 3 choices to pick. Now, what is the easiest way to tell? The easiest way to tell is this. When we say degree, I think where the confusion happened last year was we talked about it is the greatest power, but then it's actually the greatest power when everything is multiplied out. Okay, when everything is being multiplied out. So, so it would not be 2. Okay. Last year, a lot of people would pick 5 because that's the biggest number that they saw. And unfortunately, that's not the case because you have more x's to multiply together. So if you look at this, you have x squared. And then this x is going to be multiplied by itself 5 times, okay, along the whole lengthy foiling process, which we are not interested in, and we don't need to do it. But, you know, that's x to the 5th somewhere. And then you have x to the 1st power. So, and then they're all going to multiply together. So you have x squared, x to the 5th, and x, all multiplied together. So in order to help you answer the degree question, part A, and also part C, the sign of leading coefficient, I am just going to go ahead and say this. Could you go ahead and find out the first term, just the first term, with the leading coefficient, okay? And you will find out that, oh, this is x to the 8th power because you have 8 x's multiplying each other. 2 from here, 5 from here, and 1 from here. So therefore, our degree would be 8. And the reason why every single part right here it's so crucial is because that will determine your success rate of creating the graph on the right. Well, you have an even function. You have even power, but that's a negative. So again, if you think about having a negative 10 as x, okay, having a negative 10 for x raised to the 8th power, what kind of number do you get? Okay, well, multiplied by itself, even number of times, there'll be a positive number, right? But then don't forget that there's a negative sitting in front of it. So therefore, overall, the whole negative x to the 8th power, when x is equal to negative 10, it's going to be a very small number down below. So that's how we know that this polynomial is going to start low. And you're gonna get very comfortable with this kind of thinking. Just go ahead, try thinking about -10, and you're like, oh, okay, it's gonna be a small number. Cool. All right. Now, next up, now we know where it ends. Oh, where it starts, sorry. We know where it starts. Do we know where it ends? Well, same deal. Try putting it 10 for x. Okay, we had -10 for the left side. Now we have 10 for the right side. So put in 10 for x, 10 to the 8th power, big number with a negative, small number. So that's how we know we're going to start low and end low. Okay, so that's something we have to be aware of. Okay, so that's like level 2. Okay, level 2. Now our last part, level 3. Okay, what's level 3? Well, finishing the graph. So how are we going to finish the graph? Okay, like when we approach to this -2 value, how do I know that it's going to pass through, or is it going to bounce, or is it going to show some kind of turn like this? How are we going to know? Well, this is why we have this term called multiplicity, which we said in class, but it was last week. So multiplicity, it's where you see the exponents for the factors. When the multiplicity is 1, it's a simple pass-through. That would be the case right here because our root -2 comes from x plus 2 and the power it's 1. So it's a simple pass-through. Okay. And then next up, when we have x squared, we will have x squared and x squared. It's going to give you a little bounce. So we have a bounce right here, just like, every single typical parabola, it's going to see a bounce. So we have that. So it goes up and then eventually it's going to go down. But how does it go down? How does it pass through the root of x equals to 4? Well, it's the multiplicity of 5. So it's going to exhibit this little slowdown. And then it picks back up again, this kind of S-shaped turn. Okay. Make sure that it slows down as it gets closer to the root. And then it slowly leaves the root, and then it picks up the speed going more vertical afterwards. Okay, so that's the level 3. Okay, finishing the graph, and just make sure you know for a fact that you know how to interpret multiplicity, and you know how multiplicities are going to indicate different way of passing through the root. Okay, now one good way to show your understanding would be you creating a polynomial with different factors, and then you go ahead and use Desmos to try it out. You're like, let me go ahead and do x plus 1 squared, for example, and then x minus 2, and then say cube. All right, let's just say this, and you're like, oh, overall degree is 5, and then I'm expecting a bounce at x equals to -1, which we do see. And then at x equals to 2, you see that little S-shaped turn because the multiplicity is 3. Go ahead, use Desmos or anything alike to confirm your polynomial graphing skills. We're going to do more polynomial graphing in the upcoming weeks. So, that's going to be really helpful. All right, last but not least, before my voice goes away, we have x going to -infinity. So x going to -infinity, which is saying, now let me go ahead and write out the interpretation here, the translation. So it's basically saying as x goes to infinity, f of x goes to, so you would just go ahead and trace a graph and say, well, where's the graph going to? And we say it's going down. Well, it's going down. It's -infinity. Okay. What about the other one? Okay. As x goes to infinity, going to the right, then we say, oh, it's going down too. So therefore, negative infinity. So don't get scared by the arrow. It means simple things. It's just saying as x goes to infinity or negative infinity, where is the graph heading to? Okay, so do not get scared by this. So it's not that challenging. So there we go. Yeah. So that concludes our long example on the review on polynomial graphing. But you have the worksheet, so you can use the worksheet to practice it. Okay, so that's it for question number 16.